Shanghai is being swallowed from below. And the moment it happened was caught on camera for the entire world to see. On the morning of February 12, 2026, closed-circuit security cameras at the intersection of Shanghai Road and Lian Road in Minhang district recorded the asphalt splitting apart in real time. The fractures raced across the surface like lightning through glass. Within seconds, entire lanes of roadway buckled and plunged downward, dragging lampposts, construction barriers, temporary site offices, and heavy machinery into a void that ranged 10 to 20 meters wide and dropped dozens of meters deep. Dust erupted from the crater. Water jetted from ruptured utility lines into the growing chasm. Workers scrambled in every direction as the ground beneath them simply ceased to exist. One camera angle showed the collapse expanding laterally in real time, consuming additional pavement with each passing second. The footage hit Weibo and Douyin within minutes. By the afternoon, it had been broadcast by CNN, Gulf News, CCTV News, and every major international outlet on Earth. Hundreds of millions of people watched a Shanghai road vanish into the ground. But here is what stopped engineers across China cold. The destruction did not come from above. It came from below. Directly beneath that intersection, tunneling crews had been boring through saturated clay for the Jiamin Metro Line, a 44-kilometer suburban rail project linking Jiading and Minhang districts with a total investment of 37.1 billion yuan. The tunnel had breached. Water and liquefied sediment had been flooding into the excavation since the previous day, silently dissolving the earth from underneath until the road surface was resting on nothing but a thin crust of compacted fill above a growing underground cavern. When that crust gave way, the entire intersection dropped into the subway construction site like a trapdoor opening into darkness. What happened in Shanghai was not a freak accident. It was the latest eruption in a crisis that has been building beneath Chinese cities for over 2 decades. Between 2000 and 2023, researchers documented 145 separate subway construction collapse accidents across China. A landmark study published in Science in 2024 found that nearly half of all Chinese urban land is actively sinking, with more than 900 million people living on ground that is measurably subsiding beneath their feet. And Shanghai, a metropolis of 28 million souls built on some of the weakest soil on the planet, sits at the dead center of this invisible catastrophe. The question is no longer whether the ground will keep opening. The question is how many more collapses are already forming in silence beneath roads where millions of people drive and walk every single day, and whether anything built by human hands can stop what is coming next. The chain of events that led to the Shanghai Road disaster began 24 hours before the collapse. On the morning of February 11, 2026, engineers at the construction site for Section 18 of the Jiamin Metro Line detected water seepage at the receiving end of the right tunnel. The segment was being excavated between Shanghai Road Station and Xinjiang Road Station. The contractor, China Railway Tunnel Group, had completed shield tunneling work on this stretch just weeks earlier in January 2026. Now water was forcing its way through, destabilizing the surrounding soil. Shanghai Shenti Investment Company, the state-owned enterprise overseeing the entire Jiamin Line project, issued an emergency notice that evening, confirming localized seepage and activating emergency response protocols. Repair crews worked through the night, attempting to seal the breach and stabilize the waterlogged ground. They failed. By the following morning, the road surface above fractured catastrophically. Chunks of pavement, steel barrier posts, a prefabricated site office, and construction excavators plunged into the expanding crater. Multiple security cameras and bystander phones captured the collapse from different angles. The footage was authenticated and broadcast globally, becoming some of the most viewed infrastructure failure videos in recent memory. Remarkably, not a single person was killed. The area had already been cordoned off as an active construction zone, and no civilian traffic was passing through the intersection. Nearby buildings, including Moore Dental Hospital, located less than 100 meters from the crater, were evacuated as a precaution. Shanghai police later detained a 49-year-old woman for circulating a fake video generated by artificial intelligence that exaggerated the scale of the destruction, a detail that itself became a secondary viral story. The real footage needed no embellishment. To understand why Shanghai's ground fails so catastrophically when disturbed, you have to understand what this city is actually standing on. Shanghai sits on the deltaic deposit of the Yangtze River, a vast alluvial floodplain where solid bedrock lies 200 to 300 meters below the surface. Above that bedrock stretches an enormous column of soft sediment, hundreds of meters of clay, silt, and fine sand deposited over millions of years by one of the mightiest rivers on Earth. The city's average elevation is just 2.5 to 4.5 meters above sea level. The terrain is essentially flat in every direction. There is no hard rock anywhere near the surface. There is only mud. Engineers who work beneath Shanghai describe the subsurface as a multi-aquifer aquitard system, MAAS. 6 separate water-bearing sand layers sit sandwiched between 6 layers of highly compressible clay, stacked like a saturated layer cake extending to tremendous depth. The Shanghai Geological Survey identifies 9 distinct soil layers within just the first 70 meters. These layers share a devastating combination of engineering properties that makes them among the most treacherous construction environments on Earth. High water content, high compressibility, low permeability, low shear strength. The groundwater table hovers just half a meter to 2.6 meters below the pavement. Every tunnel bored through this material disrupts a fragile equilibrium of water pressure, soil compression, and gravitational loading that took geological ages to establish. Professor Jimmy Zhao of the University of Hong Kong's Department of Earth Sciences identified the compound nature of Shanghai's vulnerability. He explained that while groundwater pumping is usually the primary driver of urban subsidence, Shanghai faces an additional factor. The building density is exceptionally high, and most of the city's high-rise structures are concentrated on areas with soft soil, adding enormous weight to ground that was never designed by nature to carry it. The geology punishes overloading. The geology punishes disturbance. And Shanghai has been doing both at an accelerating rate for decades. The Kixin Road collapse of 2026 was not the first time Shanghai's subway system tore the city apart from below. The most catastrophic tunnel disaster in the city's history struck on July 1, 2003, during construction of Metro Line 4. Crews were excavating a cross-passage between the upper and lower tunnels in the Pudongnan Road to Nanpu Bridge section, where the line crosses beneath the Huangpu River. Engineers were using an artificial ground freezing method to stabilize the waterlogged soil while working through a confined aquifer with a 40-meter hydraulic head of water pressure bearing down on the excavation face. On June 28, the refrigeration equipment maintaining the frozen soil barrier broke down. When only 0.8 meters of unexcavated ground remained between the tunnel face and the pressurized aquifer, the barrier failed. A massive torrent of quicksand and water flooded the cross passage in both main tunnels. The surface above sank by up to 4 meters. The chain reaction that followed was devastating. By 9 in the morning, a 6-story building on South Zhongshan Road near the Bund collapsed entirely. Other nearby structures tilted at dangerous angles. The Linjiang Garden residential building experienced settlement rates exceeding 7 millimeters per hour, threatening imminent structural failure. The following day, on July 2, the Dongjiadu flood wall along the Huangpu River cracked and gave way, sending river water pouring directly into the flooded construction site. More than 2,000 police officers constructed emergency sandbag barriers. 4 massive cement walls, each 5.5 meters high and 2.2 meters thick, were built to seal the tunnel entrances and stop the flooding. No one died, a miracle attributable to night guards who detected the flooding and called police before the worst surface collapses began. But the damage was enormous. Rehabilitation required a 262-meter-long cut and cover tunnel, 23.7 meters wide, reaching depths of 38.5 to 41.2 meters, retained by diaphragm wall panels, 1.2 meters thick and braced by 9 to 10 levels of steel-reinforced concrete struts. The repair consumed 4 years. Line 4's complete loop finally opened to passengers on December 29, 2007, roughly 2 years behind schedule. Criminal convictions followed in November 2004. The subcontractor's deputy project manager received 2.5 years suspended, and the general contractor's project manager was sentenced to 1.5 years imprisonment. The subcontractor, Beijing China Coal Mine Engineering Company, had deviated from approved construction plans. But Shanghai's tunnel failures are only one front in a nationwide catastrophe. Across China, the collision between the world's most aggressive metro construction program and unstable urban geology has produced a pattern of disasters that is accelerating year over year. On November 15, 2008, at approximately 3:20 in the afternoon, a foundation pit collapsed at the Xianghu Station construction site in Shaoshan District, Hangzhou, during work on Metro Line 1. The diaphragm wall and steel bracing system failed across a 100-meter-long by 50-meter-wide section of the excavation, which reached depths of over 16 meters. Saturated soil flowed into the pit, burying workers. More than 10 vehicles on the 8-lane motorway above fell into the cavity as the road surface cracked open. River water flooded the tunnel to a depth of 5 meters, trapping victims with no way out. 21 people were killed and 24 injured, making it China's deadliest subway construction disaster. Direct economic losses reached approximately 49.61 million yuan. Investigation by the State Administration of Work Safety revealed that the construction timeline had been compressed, and the actual work had been delegated through multiple layers of subcontracting until roughly 400 workers from small private companies were performing the excavation with limited training and no independent safety oversight. On December 1, 2019, at approximately 9:30 in the morning, a sinkhole opened at a major intersection in Guangzhou's Tianhe district, directly above Metro Line 11 construction at Shahi Station. A street cleaning vehicle carrying a 51-year-old father and his 26-year-old son, along with a motor scooter carrying a 53-year-old woman, plunged into a hole that reached 38 meters deep. All 3 died. Security camera footage captured the moment of collapse. Public outrage intensified when reports emerged that authorities had filled the sinkhole with concrete within hours, while victims may still have been trapped alive underground. On January 13, 2020, at approximately 5:30 in the evening, a sinkhole roughly 80 square meters in area opened beneath a bus stop outside Changcheng Hospital in Xining. Security cameras recorded a public bus tipping vertically, nose first, into the void. In the footage, a young man who had narrowly escaped turned back to rescue a baby from the collapsing edge. When he and other bystanders returned to help a woman clinging to the crumbling pavement, the ground collapsed a second time, plunging the rescuers into the pit. Ruptured gas lines ignited moments later, sending a fireball erupting above ground. 9 people were killed, 16 were injured, and 4 remained missing. These are not anomalies. They are data points in an accelerating national crisis. China now operates the world's largest urban rail transit network. As of December 2024, 54 cities had 325 metro lines spanning 10,945.6 kilometers of track. In that single year, 748 kilometers of new metro opened across Chinese cities. Roughly 2/3 of all new metro track opened anywhere on the planet. Plans for 2025 called for more than 1,500 additional kilometers, with China representing 72% of all new metro construction globally. A 2025 study, published in PLOS One, analyzed these documented subway collapse cases and found that most displayed chain reaction dynamics, where a single initial failure cascades into multiple simultaneous disasters. A separate study published in the ASCE Journal of Performance of Constructed Facilities documented 334 urban road collapse accidents across China in just 2019 and 2020. The frequency is not declining, it is climbing. On February 7, 2018, a sinkhole the size of 2 basketball courts opened on an 8-lane road in Foshan, Guangdong Province during subway construction, killing between 8 and 11 people and causing 532 million yuan in damages. On October 7, 2018, in Dazhou, Sichuan Province, security cameras captured 4 pedestrians, a married couple, and a father walking with his young son, plunging through a sidewalk that collapsed without warning. All 4 died in a pit, roughly 10 meters deep. The 2024 study by Ao Zerui and colleagues at South China Normal University, published in the journal Science, measured the full continental scale of the problem. 45% of Chinese urban land is subsiding faster than 3 millimeters per year. 16% is sinking faster than 10 millimeters per year. The vast majority of China's urban population is directly affected. Annual economic losses from land subsidence across Chinese cities exceed 7.5 billion yuan. The researchers projected that by the year 2100, nearly 25% of China's coastal urban areas could sit below sea level. Robert Nichols, of the Tyndall Center for Climate Change Research at the University of East Anglia, described the findings as a national problem, not a problem in just 1 or 2 places. Shanghai has already demonstrated exactly how severe the long-term toll can be. The city has sunk a cumulative 2.63 meters since 1921, according to measurements published in the journal Hydrogeology. Peak subsidence struck between 1956 and 1959, when aggressive industrial groundwater extraction drove sinking rates to 98 millimeters per year. Some neighborhoods dropped 10 to 17 centimeters annually. 121 square kilometers of urban land experienced cumulative subsidence exceeding 500 millimeters, forming 2 distinct depression basins beneath the city center. Shanghai began fighting back in 1966 with artificial groundwater recharge, pumping clean water back into depleted aquifers to restore underground pressure. Current extraction has been reduced to less than 5 million cubic meters per year, while recharge now exceeds 25 million cubic meters annually. The citywide sinking rate has dropped to roughly 6 millimeters per year, a dramatic improvement from those peak rates during the late 1950s. But the damage is largely permanent. Research published in the Bulletin of Engineering Geology and the Environment found that sand creep deformation continues even after groundwater levels recover. The ground has stabilized, but what was lost cannot be reclaimed. And satellite monitoring reveals that stability is far from uniform. INSAR radar analysis, using Sentinel-1 satellite data, shows that while roughly 62% of central Shanghai is stable, localized zones in Minhang district still subside at 10 to 20 millimeters per year. Minhang, the same district hit by ground collapses in August 2023, January 2024, and now February 2026. The engineering required to build anything on Shanghai's treacherous ground pushes construction science to its absolute limits. The Shanghai Tower, standing 632 meters tall as the world's 3rd tallest building, weighs 850,000 tons and sits on sediment where bedrock is completely unreachable. Its foundation consists of 955 concrete board piles, each 1 meter in diameter and driven from 52 to 56 meters deep into a layer of silty fine sand far below the surface clay. The foundation slab alone consumed 61,000 cubic meters of concrete, poured continuously over 63 hours. Total construction cost reached $2.4 billion. That is the price of anchoring a single building in Shanghai's mud. Shanghai's metro network has grown from 3 lines and 65 kilometers in 2003 to over 818 kilometers and more than 500 stations today, making it the world's second longest rapid transit system and the busiest by annual ridership, carrying 3.88 billion rides in 2019 alone. The single-day ridership record stands at 13.39 million, set on March 9, 2024. New projects including the Chongming Line, the Jiamin Line, where the February collapse occurred, Line 20, and extensions to Lines 2 and 18 are all actively under construction. Every one of these projects bores through the same saturated, compressible, geologically hostile clay that has already produced catastrophic failures. Chen Biao, a Shanghai Metro project manager who has worked on the system since 1991 and oversaw construction of Line 14's Yuyuan Garden Station at a depth of 36 meters near the Huangpu River, described finding pockets of flammable methane, ammonia, and carbon monoxide trapped in ancient sediments during excavation. He offered a stark assessment of the risks involved. Surrounding structures such as roads and buildings face immediate danger the moment the ground sinks too much, and pumping water out too rapidly during construction can trigger exactly that outcome. Then he added something that no amount of engineering confidence can fully answer. In the end, you cannot take full control of what will happen tomorrow and the day after. China's regulatory response is accelerating, but remains largely reactive. The national standard for underground disaster detection and risk evaluation was not issued until 2018. Satellite-based interferometric synthetic aperture radar monitoring can now detect precursory subsidence signals 12 or more months before a collapse occurs. But as of 2019, only Shenzhen and Chongqing among all of China's cities had dedicated government departments for managing land subsidence risk. Shanghai operates under a 2013 regulation dividing the municipality into 3 subsidence control zones, but enforcement depends on the same construction ministries that face political pressure to deliver new metro lines on schedule. Every week, new shield tunneling machines advance through Shanghai's waterlogged clay. The Jiamin Line remains under active construction. The crater on Qixin Road has been filled with stabilizing material, but the geological conditions that produced it are unchanged and unchangeable. Monitoring data from Shanghai's oldest metro line shows that the ground above Line 1 tunnels sank a maximum of 288 millimeters over 12.5 years of operation. That is not construction damage. That is the Earth slowly closing around the tubes that humans threaded through it, compressing under loads it was never asked to carry. Multiply that process across more than 800 kilometers of tunnel, beneath a city that invested 238.3 billion yuan in major construction in 2024 alone, and the scale of the ongoing negotiation between engineering ambition and geological reality becomes clear. Shanghai has experienced more than 100 ground collapses over the past 2 decades, averaging more than 4 per year. Beijing recorded 99 sinkholes in a single 22-day period during one summer. These are not extraordinary events. They are the baseline. The ordinary background noise of a civilization building faster and deeper than the ground beneath it can adjust. Beneath Shanghai right now, somewhere in the dark between 2 stations that do not yet exist, a shield machine is rotating forward. Pressurized slurry holds back the face of the excavation. Sensors measure settlement in fractions of a millimeter. And somewhere above that machine, on a street where traffic flows and vendors sell breakfast and commuters check their phones, the asphalt holds. For now. The instruments are watching, the satellites are mapping, the engineers are calculating. But the soft clay follows its own mathematics, and it has been settling accounts with this city for longer than anyone has been measuring.